Start by imagining you open a spreadsheet and see a column labeled temperature. Every cell is a number. Some are 21, some are 72, some have -5. What do? Do you plot them, convert them, send an alert? The core problem here isn't arithmetic, it's meaning. And that's exactly what this video is about. The difference between explicit meaning and implicit meaning in data, and why both matter. We introduced semantics in the last video, syntax versus semantics, the idea that data's form is different from what it stands for. Now let's zoom in. Explicit semantics are the meanings we intentionally attach to data, the labels, units, schemas, and documentation. Implicit semantics are the meanings that live in context, how a team collects, stores, and uses the data, the assumptions baked into a field, or habits that evolve over time. Think of explicit semantics as the signs on a museum wall. They tell you the artist, the year, the medium. Implicit semantics is what the curator and the audience already know, that this painting belongs to a certain movement, or that the lighting in the gallery makes colors look warmer. Signs are explicit, context is implicit. Both guide interpretation. Let's start with explicit meaning, because it's the easier one to fix. Explicit semantics are the artifacts you can write down and ship with a dataset. Field names, types, units, data dictionaries, schemas, API docs, and ontologies. If a column is called length meters, that's an explicit promise. If a JSON schema says a field is an integer between 0 and 120, that's explicit. These are powerful because they let machines and humans reason about data automatically. Tools can validate, type check, and convert. Pipelines can reject bad inputs. Consumers can join datasets with confidence. But explicit semantics come with caveats. First, completeness. Many datasets are underdocumented. A field labeled score without explanation is an invitation for error. Second, fidelity. Documentation can be wrong or stale. Someone may rename a column but not update the data dictionary. Third, granularity mismatches. One system's country code might be ISO 2, another might be ISO 3, or a local abbreviation. If explicit semantics disagree across teams, you still get subtle errors. Now to implicit meaning, the darker, slipperier half. Implicit semantics are the assumptions embedded in practice, how data is collected, what business process produced it, how missing values are treated, and even the political compromises that shaped a field. A status column might be implicitly ordered by severity in one team and alphabetically in another. A timestamp might be local time in one system and UTC in another. Often, there's no single authoritative document that explains these choices. They exist in tribal knowledge, emails, code comments, and the habits of a handful of engineers. Why do implicit semantics matter? Because they're where most surprises hide. Two datasets with identical explicit metadata can still mean different things if their implicit context differs. Imagine merging customer lifetime metrics from two regions where active user is measured differently. Your churn analysis will look plausible, but it will be wrong for the wrong reasons. So how do you manage both? Here are practical patterns I've seen work. Make explicit semantics rigorous and visible. That means a living schema, a well-maintained data dictionary, and codified units and enumerations. Put these artifacts close to the data, not in a static PDF, but in the system that produces or serves the data. Machine-readable schemas and API contracts are your friends because they let tooling block obvious mismatches, capture and expose provenance and lineage. Who produced the data? What transformation steps ran? When and where did conversions happen? Lineage is the bridge from explicit to implicit. If you can trace a bad value back to a specific ingestion job and timestamp, you can see whether the semantics changed at that point, say a sensor swap or a new ETL script. Use controlled vocabularies and ontologies when needed. For domains where semantics are shared across teams, healthcare codes, product taxonomies, geocodes, a standard ontology prevents semantic negotiation each time you integrate. It's extra upfront work, but it scales. Test semantics, not just syntax. Unit tests for data. Check that units haven't changed, distributions look consistent, and categorical values remain in expected sets. Monitor for semantic drift, changes in meaning over time, with statistical tests, anomaly detection, and human review. A sudden spike in response time might mean a code regression, or it might mean the metric switched from milliseconds to seconds. Tests help you catch the latter before decisions are made. Encourage human-readable narratives. A field's metadata should include why the field exists, not just its type. This column tracks the last login timestamp used for billing calculations is far more actionable than timestamp:"daytime." The why helps future engineers reconstruct implicit semantics. Define contracts between teams. Data contracts are agreements. This field will exist with these units and in this format, and if it changes, we'll notify consumers. Contracts make implicit expectations explicit before they break downstream systems. Build discovery and cataloging. A data catalog that surfaces usage examples, sample records, and consumer comments helps surface implicit semantics. When you can see how others use a field, you can infer the unstated assumptions. There are also reconciliation patterns when semantics don't align. Mapping layers convert units, normalize enumerations, and translate identifiers. Semantic mediation can be automated to an extent, but often it requires human judgment. That judgment is a valuable data asset. Treat it like intellectual property, document it, and share it. Let's pause for a moment on semantic drift. It's one of the trickiest failure modes. Over months and years, the meaning of a field can subtly change. A form gets updated, a sensor is replaced, a product team redefines active user. The code keeps running, dashboards keep updating, and nobody notices until a critical decision was made on the wrong baseline. Combat drift with a blend of automation, governance, and curiosity. Automation provides alerts on distributional change. Governance introduces change management and release notes for schema changes. Curiosity means regular data reviews. Finally, remember that explicit and implicit semantics are complementary. Explicit documentation improves discoverability and automation. Implicit knowledge captures the lived reality of systems. Your job as a data professional is to translate implicit meaning into explicit artifacts where possible, and where it can't be fully codified, to make it discoverable and testable. To bring this home, explicit semantics are the labels and rules you write down. Implicit semantics are the stories you inherit. Make the labels clear, record the stories, test both. Because when you do, you turn scattered numbers into durable, trustworthy signals.